Hi, welcome back to my channel pibyme Maths. This is Vasudevan. Here we are solving May June 2019 Pure Math 1 paper. In the previous video we looked at question number 1 to 5. So let's jump into question number 6 now. The line with the equation y is equal to 4x plus c, where c is a constant, meets the curve with this equation. At only one point find the value of c. So we are going to equate them. X times x minus 3 is equal to 4x plus c. So x square minus 3x, bring the 4x also this side, minus c is 0. So x square minus 7x minus c is 0. Coefficient of x is a, coefficient of x square is a, coefficient of x is b, the constant term is c. So if a line and a curve meets at only one point, the condition is b square minus 4ac is equal to 0. So b square minus 4ac is equal to 0. Make c as a subject. So 49 plus 4c is 0. c is minus 49 over 4. That's a simplified fraction. Keep it as it is. You don't have to change it to decimal. Part B now. Hence find the coordinates of the point of intersection. Now we need to sub in the value of c in here and then solve the equation. So x square minus 7x, x square minus 7x minus c. c has a negative sign also. Multiply throughout by 4, you will get 4x square minus 28x plus 49 is 0, which is a quadratic. Solve the quadratic equation. 4 minus 28 plus 49. 7 over 2. Just only one point, right? They both intersect at only one point. So it's basically 7 over 2. X is equal to 7 over 2, 7 over 2. So you can write this as 2x minus 7 times 2x minus 7. You have to mention this. So just x is 7 over 2. To find the y coordinate, sub in this value into any one of the equation. So x is equal to 7 over 2. I'm going to take the equation of the curve. Y is equal to x times x minus 3. So x times x minus 3. So it's 7 over 2 times 7 minus 6 is 1 over 2, which is 7 over 4. Therefore, the point of intersection is 7 over 2, 7 over 4. That's the x and y coordinates of the point of intersection. Question number 7 now. We have a diagram given and this is from radian. So usually in the first few lines of the question they are going to describe the diagram. So it says the shape ABCDA consists of a sector ABCOA joined to a triangle AOD. Okay, a sector ABCOA. This is a sector, a major sector. So if you are finding area or arc length of the sector, you need to use this angle, interior angle, and then there is a triangle AODA, right? That's what it says. Point D lies on OC. Point D lies on OC. Okay, and then it says the radius of the circle is 6, AD is 5. The radius of the circle is 6. So this is 6. That means OC, the total length, is also 6. And AD is 5. This angle is 0.7. Find the area of the sector. We need to find the area of the sector. So we need this interior angle. We know this little angle and the angle around a point is 2 pi. So this angle will be 2 pi minus 0.7, right? So area is equal to half r square, square of the radius, times the interior angle, which is 2 pi minus 0.7. Half times 6 square times 2 pi minus 0.7. 100.497, 100.5 centimeter square. And then I store these values A immediately. Part B now. Given that ADO is obtuse, find the angle ADO. Okay, I have copied the figure here. They want you to find this angle ADO. So I'm gonna take the triangle separately, AO, and then AD is here. Oh, this is OD. This is 6, 5, 0.7. We have two sides and two opposite angles. One of the angle is missing. We can apply sine rule. Okay. To apply the sine rule, sine ADO, the angle ADO over the opposite side is equal to sine 0.7 over 5. So sine ADO is 6 times sine 0.7 over 5. So from here you can find the angle ADO to 3 decimal place. So now we need to make sure the calculator is in radian mode. 6 times sine 0.7 over 5. Sine inverse of this answer. Okay, we got the answer 0.88 dot 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 dot. But the question says it's an obtuse angle, so we need to check whether it's obtuse angle or not. If this value is bigger than pi over 2. Okay, so I'm gonna store the value first as b. Pi over 2 is 1 point something, so it is an acute angle, right? So what we need to do, therefore ADO is equal to pi minus 0.88. You need to subtract from pi and write the answer. That would be the obtuse angle. So you write pi minus, we store the values b. They want the answer to 3 decimal place, 2.258. 2.258 radians. And then immediately store the value. So if we need this angle in any other calculation, we are going to use not the rounded one, actual value. Part C now. I have copied the figure here again. Find the perimeter of the shape ABCDA. They want you to find this perimeter, this line CDA. So we can find the arc length first. Arc length is radius times theta, 2 pi minus 0.7. That's the angle, right? Interior angle, right? Okay, we can calculate this. And we know AD. We need to find CD. We know the total length is the radius 6, right? So if we know this little length here, OD, we can subtract it from 6, right? So how to find OD? We know this angle, we just calculated this angle also, so we can find the third angle, right? So you see how I am using the sine rule, because I'm going to use this angle opposite side, this angle opposite side. So sine, how do we find this little angle? Angles in a triangle add up to 180 or pi. So this angle will be pi minus 0.7 minus the angle we just calculated, 2.25, divided by the opposite side is OD is equal to sine 0.7 divided by the opposite side. Hope you understand this. Or just put it as OD divided by, it's the same thing. So you can just flip both sides. So OD is going to be 5 times sine pi minus 0.7 minus 2.25 dot dot dot, everything divided by sine 0.7. That's gonna be the length of OD, and then we can find the perimeter. So let's find the arc length first. No, maybe we'll do it. We'll calculate this first. 5 times sine pi minus 0.7 minus the angle has been stored as B divided by sine 0.7. That's 1.417 dot dot dot. So we got this length OD, but we don't need OD to find the perimeter. We need CD, right? CD is the total length 6 minus whatever we got just now. So maybe here you write 1.41 dot dot dot. So CD is equal to 6 minus 1.41. 6 minus the answer 4.58. 4.58 dot dot dot. I'm gonna remove the figure here. I'm gonna write perimeter is equal to the length AD, this 5, plus the one we got just now 4.58 dot dot dot, plus the arc length. So this answer plus 5 plus 6 times 2 pi minus 0.7, close the bracket and round it to one decimal place. That's 43.1 centimeter. That's the arc, the perimeter of the shape. Question number 8. We have f dash of x given straight away. They want you to find the equation of the normal. So first find the slope of the tangent. You need to sub in the x coordinate in here. That's f dash of 4 is 4 square root of 4 minus 2 minus 8 over 3 times 4 square. 4 square root of 4 is 2. 4 2s are 8 minus 2 minus 8 over 3 times 4 square. You're gonna get 35 over 6. That's the slope of the tangent, but we need the normal, equation of the normal. So slope of the normal is a perpendicular line to the tangent, so take the negative reciprocal of the slope. So we have a slope, we have a point, take the point as x1, y1. The equation is y minus y1 is slope times x minus x1. They want the equation in this format without fraction. ABC are integers, so multiply throughout by 35. 35y minus 35 is minus 6x plus 6 4s are 24. Move everything this side. 6x plus 35y minus 59 is equal to 0. That's all. That's the equation of the normal. Part B, find f of x. Okay, we have f dash of x is equal to 4 square root of x minus 2 minus 8 over 3 x power minus 2 if you put it in the numerator. So f of x, when you integrate both sides, you will get f of x is 4x power half plus 1 over half plus 1 minus 2x minus 8 over 3 x power minus 2 plus 1, which is minus 1 by minus 1 plus c. So f of x is, this becomes 8 over 3 x power 3 by 2 minus 2x positive 8 over 3 x power minus 1 plus c. Now we need to find the value of c using the point. The point lies on the function, right? So replace x by 4, y by 1. So x by 4, f of x by 1, not y by 1. So 1 is equal to 8 over 3 times 4 power 3 over 2. 2 times 4, 8 over 3 times 4 power minus 1 plus c. So it's going to be 1, this bring the first term this to the left side, minus 8 over 3 times 4 power 3 over 2 is basically 8, because 4 is 2 square, right? Or you can just write it as 4 power 3 over 2. Minus 2 4s are 8, comes this side, becomes plus 8. And the next term was positive, comes here negative. 4 power minus 1 is 1 over 4. So 8 over 3 times 1 over 4 is 2 over 3. 2 over 3 is minus 13. That's the value of c. But once you got the c, you have to write the function at the end, otherwise you will lose a mark. So f of x is equal to 8 over 3 x power 3 over 2 minus 2x plus 8 over 3 x power minus 1 minus 13. That's the function. Question number 9 now. We have a graph given. The question says, figure 3 shows a plot of the curve sine theta from, just a sine graph from 0 to 360. State the coordinates of the minimum point on the curve with the equation 4 sine theta. Look at this one. The minimum point here is 270 degree comma minus 1, right? For sine x. Okay. But they are talking about 4 sine theta. So you need to multiply the y coordinates by 4. So it's just 270 degree comma minus 4. That's all. No working needed. Part B, a copy of figure 3 is given. I have put the figure a bit bigger here. They want us to sketch these two graphs on top of this diagram. 1 plus sine theta and tan theta. So let's sketch 1 plus sine theta. 1 plus sine theta. You need to use your pencil. You cannot use any colors in the exam. So this is sine theta. When they say 1 plus sine theta plus 1, you need to move the graph upwards 1 unit. So instead of 0, we are going to start from here. It goes all the way to here. Instead of minus 1, it will come to 0 on this. Touching the x-axis here. And label it 1 plus sine theta. They just want us to sketch, right? We don't need to mention anything else. Yes. And then we are going to sketch tan theta. For tan theta, there is an asymptote at 90. Another asymptote at 270. So you need to draw the top part of the graph. And then the full graph here without touching the asymptote. Here only the bottom part. Label it y is equal to tan theta. That's all. Now, hence find the number of solutions of the equation tan theta is equal to 1 plus sine theta from 0 to this. Okay. I have taken both 1 plus sine theta and tan theta here. So this is 90 degree, 180, 270. This is 360. Okay, this is x-axis and y-axis. Now they are talking about the point of intersection of these two graphs. When they say solution to this equation, that's same as point of intersection of these two graphs, right? And in the interval 0 to 2160, okay, when we divide 2160 by 360, we are getting 6. What does that mean? If we divide 2160 by 360 intervals, there are 6 intervals actually. So by looking at the point of intersection between 0 to 360, we can say how many point of intersection are there in this interval. Here you can see 1, 2. There are 2 points of intersection, right? And the graph is uniform in every 360 interval, because if you copy this whole graph, paste it here, you will get the extension of the graph, right? That means it's going to look like the same actually. Nothing changed, right? Even in the next 2 pi interval. So definitely we can just multiply this point of intersection by 2. So just simply write 6 times 2 is equal to 12 solutions, not point of intersections, right? 12 solutions. Okay, double I now. How about 0 to 1980? Let's see how many 360s are there. 1980 divided by 360. That's 5.5. What does that mean? There are 5 360s are there. You see, 5 times 360 is 1800. So it's basically 1800 plus another 180. So there are 5 360s, so you can put 5 times 2 plus another 180 interval. So you need to look at the graph from 0 to 180 and check how many points of intersection are there. Only one, right? This one, right? So you need to write 5 times 2 plus 1 is equal to 11 solutions. That's all. Question number 10. A curve has the equation y is equal to f of x. That's a cubic function. The curve touches x-axis at P, crosses x-axis at Q. Find the coordinates of P. Okay. There are 2 x-intercepts. When you equate it to 0, you will get x is equal to 4, x is equal to minus half. But this minus half is a repeated root, right? Because it has a square. So you need to remember this when we sketch a cubic graph. If there is a repeated root, the graph will touch the x-axis at the repeated root and crosses at the other root. So whenever you have a repeated root, that's where the curve touches x-axis. So it says the curve touches x-axis at P, so P will be minus half comma 0, and then they don't want you to find Q here, but Q is this point. Q is 4 comma 0. So the answer here is just write this point, you'll be given 1 mark. Find f dash of x. So write f of x first. X minus 4 times 2x plus 1 whole square, expand it. A plus b whole square is a square plus 2ab plus b square. Open the bracket, multiply everything by x, 4x cube plus 4x square plus x. And multiply everything by minus 4, minus 16x square minus 16x minus 4. So f of x is going to be 4x cube. Simplify the like terms. 4 minus 16 is minus 12x square. 1 minus 16 is minus 15x minus 4. Now just differentiate it. 4 3s are 12x square minus 24x minus 15. That's all. Just a simple differentiation question. Let's move on to part C. Hence show that the equation of the tangent to the curve at this point can be expressed in this form. Okay. We have the x coordinate. To find the y coordinate, we need to sub in this point into the function. The function is x minus 4 times 2x plus 1 whole square. When you replace x by 5 over 2, you will get the y coordinate. 5 over 2 minus 4. Don't sub in here actually. You can sub in here, you will get the same answer, but this will be a lot easier. You see, 2 times 5 over 2 plus 1 whole square. So it's 5 over 2 minus 4. And then this one, 2 will be cancelled. 5 plus 1, 6 square times 36. you'll get negative 54. The point is 5 over 2 comma negative 54. Now we need to find the slope. We have f dash of x, right? F dash of x is 12x square minus 24x minus 15. Replace x by the x coordinate of the point to find the slope. So f dash of 5 over 2 is 12 times 5 over 2 whole square minus 24 times 5 over 2 minus 15. Let's calculate this. 12 times 5 over 2 whole square is 25 over 4 minus 24 times 5 over 2 minus 15. Okay, the slope is 0. The slope is equal to 0. So you can write the equation as y is equal to mx plus c. Y minus y1, use the point. Y minus y1 is equal to slope times x minus x1. The whole thing becomes 0. So y is equal to minus 54. That's the x coordinate. Sorry, that's the equation of the tangent. It looks like this, right? Y is equal to k. That means it's a line parallel to the x-axis. Part D now. The curve with the equation f of x plus a. Okay, we have f of x, which is x plus 4 times 2x, x minus 4 times 2x plus 1 whole square. Now they are talking about f of x plus a. It's a translation along x-axis. If a is positive number, it's a translation to the left side. If a is negative, it's translation to the right side, right? So there are two translations involved depending on the value of a. But when you apply this transformation, the curve passes through the origin. So state the possible values of a. Okay, let's look at the curve. This is the curve. It touches at minus 1 over 2, crosses at 4. You can move this graph to the left side or right side, but the only condition is it has to go through the origin. So how many units you move the graph? If we move the graph to the left side 4 units, you will get the graph like this. So it will pass through the origin, right? So that's one option. When you move to the left side 4 units, the function is f of x plus 4. So a is equal to 4. That's one option. Or you can move the graph to the right side half units. So you will get this graph. It will pass through the origin and the function is f of x minus half. So a is equal to minus half. These are all the two values. That's all.